So Dataprime, you can see what we're doing at dataprime.ai. So check that out at some time you wish. So message number one is, I like to say there's nothing artificial about AI. Okay, so even though we call it artificial intelligence, there's really what I would say nothing artificial about AI. And so I started thinking about a lot of the different ways we boost our intelligence using AI in the workplace and in our research and in industries and wherever we're working. And all of a sudden I realized that there are a lot of A's involved, like accelerated intelligence, actionable, assisted, augmented, adaptable, amplified, automated. And so they all started with A, and so maybe that was a little bit forced, but I think it's not too forced. For example, assisted helps people do their jobs better. So I like to think of the example of a contact call center where AI is helping the call center representative assist them in bringing up information, for example, about a customer automatically during the conversation. It also augments the work of the call center representative by providing extra insights into the customer, for example, applying natural language processing to what the customer is saying, even sort of emotion or sentiment detection. It can amplify the work of the call center by actually doing the work of multiple call center representatives and for example, answering some of the more simple type of calls where people are just say, what's the balance on my account? Or what's your address so I can return the product? So some of those things don't need to talk to a human being. So it can amplify the outcomes and performance and productivity of a call center by taking some of that load from humans and putting it on the AI. So these things can be automated, but it's also adaptable in the sense that machine learning is adaptable, that it learns from experience. It learns from patterns in the data, and it learns from patterns in the application of the AI, how to improve it and to make it better. So I think about all these different aspects of accelerated intelligence and all these things. And I gave a talk on these 7 A's a few years ago. And one of the people in the audience was Mariah Yao. She's one of the world's leading writers and thought leaders around AI. And we talked after my talk, and she said, you need to add one more A. And she told me, put awesome intelligence in there. So that's not my suggestion. She suggested, so there's the 8th A, there's awesome. So this is what AI does for it. It actually boosts a lot of things in our day-to-day life. So the second major message about AI is that it devours data, that it just consumes large amounts of data in the same way that a human, very cognitive human, navigates through our world and our life, at every part of our life, by absorbing information through our senses, right? Through our eyes and ears and everything. And so the AI is consuming large amounts of data to deliver basically a cognitive approach to navigating in our world. And so AI consumes enormous quantities of data. I just list a few here on this slide. So AI is one of these emerging technologies. So here's a long list, probably a little hard to read all the words there, but 5G and robotics and drones, deep learning, virtual assistants, including those conversational AI assistants in the call center that I mentioned, machine learning, virtual reality, augmented reality, and many more. So there's a lot of things here. So this rapidly expanding frontier of emerging technologies actually, in a lot of cases, if not probably all these cases, these are innovations inspired by data, informed by data. That is, the data makes it possible. It is enabled by data. And the amazing thing and good thing is that it's creating value and jobs from data. But if you think about what AI is, again, is that accelerant, that boost, that amplifier, that assistant, it's actually driving the edge of this frontier. So the edge of the innovation frontier is moving forward with new innovations and even the deployment of the ones listed here with the help of AI. So AI is not just itself an emerging technology, but it's actually part of the story of emerging technologies. So the talk that I'm going to give in October is going to go through about 10 of these. Okay, so they're listed here, the 10 specific data devouring applications that I'm going to go into more detail when I get to the talk in October. So I'm not going to give too much detail here. So machine learning, AI itself in the context of actionable, assisted, augmented intelligence, robotics. So I have a little picture down at the bottom of a robot traveling through a warehouse at a store, and it's using maybe computer vision or scanners or things like that to note and keep track of what's in the inventory, how fast things are moving off the shelves, what needs to be reordered, and so forth. So it's all done robotically. It doesn't require a human anymore to do that. Then we have drones. So again, these are things that I'll be talking about in detail in the future talk. So autonomous vehicles. So there's a little graphic down there of a moving video where deep learning and computer vision actually in real time can identify objects in the view of the car. So it's not just moving things like cars and people, but also stop signs and other kind of traffic signals. And also just sort of the context of the environment. If it's around or near a school and children are playing, even though the children may not be in the street, potentially they could go into the street because children, you might chase after a ball or some plaything. Excuse me. Then we're getting to number 6 here, one of my favorites, 3D and 4D printing. And so 4D printing is basically dynamic time-changing devices that change shape in response to inputs from sensors. Okay, so it's definitely data-driven inputs from sensor, real-time dynamic data that can use to change the shape of something. And if you don't know about 4D printing, there's a great TED talk on it that talks about heart stents. So it was put into the heart of in the arteries of a person, and through the sensors in the heart stent, it actually can change shape. So it's designed and built with carbon nanotubes, and the sensors, which are microscopic sensors, can sense the heart rate or the blood pressure or the body temperature or the stress level of the person, and actually change the shape of the heart stent in response to the need of that particular patient. So we get virtual reality and augmented reality. So there's a little graphic down there at the bottom of augmented reality where this a retail application where a person is trying on clothes in a store, and they don't actually have to try them on. They can stand in front of this augmented reality mirror, which actually superimposes the different clothing choices, and you see yourself in the mirror with those particular clothes on without actually having put them on. So these again are data-driven and AI applications in the real world. And number 9, we have Internet of Things. It's a multi-trillion-dollar industry over the next decade. So I've heard one organization say, get your resume ready, because the IoT is going to change the world of work, change the world of industry, and create jobs everywhere. And then more generally, number 10, dynamic data-driven application systems. So I will summarize all these things in the full talk in October. As a summary, at the end of that talk, I'm going to go into these 10 sort of predictions of AI advances over the next few years in a variety of different industries. So agriculture, automotive, customer service, education, finance, healthcare. You can read the list here: journalism, manufacturing, marketing, and security. So some of the words are grayed out, so you can't read them, and that's fine, because I'm going to talk about that in more detail in the full talk. But we'll look at these sort of the future of AI and these 10 examples from these 10 industries. So that's the high-level summary. I encourage you to come back and join us in October. Join me and all the other speakers to see what we're talking about, specifically this future of AI and creating value at the convergence of emerging technologies.
Thank you, Dr. Borne, for that excellent preview of your talk. You almost laid the foundation for mine, and I completely agree with you. AI is going to change the way we live, the way we work, and it's such an important area. And I am going to be talking about a specific, subset of the larger AI field, right? And my talk, the preview, and I must also remind, this is just a preview of the talk. The Global Big Data and AI Conference is scheduled, as Murthy mentioned, from October, I think, 11th to 15th. And my talk is scheduled for October 12th. So I highly encourage you, after this preview, if you're interested in the field of NLP research, to come back and attend the full talk. But essentially, so my talk is in the field of text summarization, which is in the field of natural language processing using deep learning. And I'm Anjali Shah, and I'm a senior data scientist at IBM. So what exactly is text summarization? So, it's a very, very important problem in the field of natural language understanding and natural language processing. in our lives, right, in our day-to-day lives, there is a ton of textual unstructured data that we have to deal with. And what if we can get AI to generate concise, coherent summaries of all that information by paraphrasing the original text for us? Wouldn't that be great? A very important application area, and that is exactly what my talk will focus on. Text summarization, using deep learning, when we talk about it, can be sort of divided into two important subcategories. One is extractive summarization, and the other one is abstractive summarization. And I'll give you a key difference between the two. When we talk about extractive summarization, what we're looking to achieve is, let's say, from a long document of text, we're looking to find out what are some of the most important sentences that will help summarize the entire body of text for us. So it's no new language generation there. It's just picking up from an existing body of text and then summarizing that way. But there's no net new language generation in extractive summarization. On the other hand, abstractive summarization involves generation, natural language generation. And what it does is, from a body of text, it tries to understand what the context is, and then it paraphrases, often generating new language, how to concisely and very coherently reflect what the message might be. And this is a very difficult topic to address within the field of summarization. But with recent advances in the field of deep learning, especially natural language processing, and with the advent of the transformer-based architectures, we've seen a lot of exciting progress in this field of abstractive summarization. And so that is what will be the focus of my talk on October 12th. But if you look at a lot of recent research, it focuses on summarizing data sets from news and media. So when we did this work, we focused on summarizing domain-specific documents, because in our day-to-day work, working with many different clients from different industries, we wanted to see how we can apply some of the strategies on very domain-specific documents. And when we talk about domain-specific, let me highlight, right, across industries, what are the different applications and use cases of text summarization? And there are many. We just talked about news and media monitoring. These news and media companies, they're receiving information, every minute from around the world. And they need to quickly gather summaries of all this data that's flowing in and be able to convert it into a format where they can deliver it to their downstream audience in a timely manner. And so summarization is something that's very key to the news and media industry. And a lot of recent research focuses on using some of these news and media data sets. But it's not just the news and media industry. There are a lot of other industries that can also benefit from summarization. And let me explain how. Let's look at the financial services industry. Let's take the example of an asset manager, right? As an asset manager, let's say you're supposed to generate a fund sheet, like a fund fact sheet for your clients. And in order to generate such a fund fact sheet, you might be required to sort of not just keep yourself up to date on all those companies that you're looking to invest in or already invested in, like all of the financial events related to their company, but also you need to look at all the financial statements generated by the company. A lot of information, a lot of unstructured text information that you might have to look at in order to generate that report or summary. And if AI can help you do that, some of the facts, the figures to add to your report, wouldn't that be helpful? I mean, this is exactly some of the use cases we are working on with our clients. Now let's shift focus to the medical industry. like our doctors and nurses, on the front lines, and we've seen this past 2 years with the pandemic, they are on the front lines taking care of the patients. And at the same time, there's a lot of new research coming out in the medical world that might benefit their patients, but how do they stay on top of all of that, right? They're on the front line serving the patients, providing value, providing care. But at the same time, how do they stay on top of all of that research that might benefit their patients? And that's exactly where we can put AI to use, real good use, where, based on the patient summaries from, let's say, the electronic health records, the AI can help find what might be related to this specific patient care scenario, and help pop that up in the EHR by providing a summary of what the doctor could use as a line of treatment. And so certainly, summarization is very key there. Another very important area is search engine optimization, where summarization is used very heavily. For example, people want to understand, let's say, what their users want to view on their website, or improve their users' experience on their website. So they can analyze, let's say, content from their competitors' website and see, based on their users' behavior on their website, if it's serving them well or not, and accordingly make changes and create new content, or make changes to the content on the fly. So that's another very important area. Legal, a lot of legal documents tend to have a lot of legal jargon, and if we could get AI to generate quick, succinct summaries for us, why not? Like, this is a big winner for the legal field as well. And last but not the least, we see a proliferation of chatbots. A lot of websites that we tend to visit have chatbot services, these chatbots need to understand from the users gist of the question being asked, and that also requires summarization, text summarization, and understanding what the question might be, so that they can come back with a relevant answer. So again, just to highlight, text summarization using deep learning has many different applications and use cases across different industries. So very important area within artificial intelligence, using deep learning, and there is a lot of progress that has been made, and which is what my talk will focus on. And if you attend the talk, what you're going to learn about is, I'm going to provide a lay of the land. We'll give you the overview of the most recent state-of-the-art models in the field of text summarization. I'm also going to provide links to a notebook which applies Hugging Face library. So if you're in the NLP space, you might have heard of this library, Hugging Face. It's an excellent library. It also provides data sets. So the notebook looks at a build-some data set from the Hugging Face library. And we'll use some of the models from the library on the build-some, which is a more of a domain-specific data set. And the reason why we picked this data set is we want to see how we can perform abstractive summarization on these very specific, domain-specific documents, where the context is not just localized, right? It might be sort of long range within the document, and see how the model performs. And so, if you are a machine learning scientist or a data scientist, this talk might be very interesting to you, especially if you're in the NLP field, or looking to get started with NLP, which is a very exciting area of research. So I would say, yeah, definitely, keep this talk in mind. Which is, I think, scheduled for October 12th at around, I believe, 1:15 p.m. Eastern. So, yeah.
Thank you. Yeah, thank you very much. I'm very excited to be back on both topics that we've addressed, and we have two sessions. One session on Tuesday, October 12th at 1:50 p.m., which will talk about maximizing the productivity of your ML platform using Kubeflow 1.4. 1.4 being the community's 12th release of Kubeflow over the last 3 years. And then on Wednesday, October 13th at 2:25, we'll start a machine learning workshop that will run several hours. It'll have 6 sessions and multiple speakers. You can see some of the speakers here and a broad variety of perspectives. From Wells Fargo, we have the EVP of corporate model risk. We have David from Fairly AI, which is a leading startup in developing these systems around simplifying the way that financial institutions deal with model risk management reporting. Myself from the ML platform community, primarily representing Kubeflow and Aricto. Aricto is the company that I work for, and they contribute quite a bit to the Kubeflow community. Nicola is a professor at a leading institution, university in Canada, and Stuart being a data scientist. So you can see we have a broad view of folks that will be providing talks in different requirements as it comes to financial institutions and producing the reports and the governance required to make sure that really financial institutions are protected as they deploy machine learning models into production. And I think it's going to be a really fantastic session for folks. You know, from a perspective of what I am going to talk about in particular is really about Kubeflow and how Kubeflow is reducing the amount of time and effort that teams need when they're building a machine learning platform. The idea is to take the process of building the platform and building a model. So those are 2 different things. First, you have to build a platform by picking a bunch of different tools to do all these different life cycle processes and stringing them all together. What Kubeflow does, based upon an open source project that is out of Google, is it takes this life cycle for machine learning, everything from model building to distributed training to building a pipeline to deployment, and has run this natively on Kubernetes using this declarative operational capability, which saves both operational time and infrastructure time. So this is really the promise around Kubeflow that you'll learn more about as we go through this. As the Kubeflow community manager the last few years, I've set up user surveys and talked to the folks that are using these platforms. And you can see here, we have ML engineers and architects, as well as data scientists, data engineers giving us input about how the platform should be modified or updated or improved in each release. We do that about every 4 months. But one of the things that came out of all those question and answers that we did in the survey is that model life tends to be fairly short for a lot of companies. Some companies, are replacing models as quickly, 11% replace them as quickly as a week. We're not saying that you need to replace models as quickly as a week, but it's nice to be able to know that you can do that. 13% say within a month and another 26% say within 3 months. But the other part of this really comes down into model versioning, right? So even though you're replacing your models, you may not get it right the first time. So, new data comes in, new code comes in. This is telling us that the users are saying that it takes almost 15 versions or iterations to be able to come up with a final model that you'll put into production. And even if you only have 10 models that you're putting into production, which wouldn't be very much, that could be one small department in a large bank, right? You're replacing those every 90 days. And you're doing 15 iterations of every model. You can do the math, right? You have a lot of iterations. So one of the things that may be a little unorthodox that I wanted to show today in this teaser is a couple of workflows, a work protection workflow, as well as how to debug a pipeline. I'm just going to jump over real quick so you can see some of the things that we'll talk about as we get into Kubeflow. And this is only one portion of many of the talks that we'll have, but Kubeflow this is the central dashboard. This gives you kind of a good view of all the different components that Kubeflow provides. I'm just going to, in the interest of time, jump into this notebook. Many people experiment in data science in notebooks. This is one from a Kaggle competition. It's for vaccine degradation, and it's based on the COVID mRNA molecule. And basically, it's trying to determine which of these bases or branches off this molecule are going to be good to produce a vaccine from. Which ones are prone to cut, probably not good to build your vaccine on. Safe from degradation, this is the place where you want to build your model. But as you're walking through this, what I just want to show in the first kind of use case quickly is I'm installing some packages and libraries, right? I want to be able to protect those in a snapshot so I can reproduce and share that. But the other thing is I have all this code that I have in this notebook, and I get it going, and I have all these steps, and I get it to a place where I like it. Now I want to build a pipeline, right? And what the pipeline does and looks like is something like this, right? So if we were over here, there's a load data step, a pre-process step, a model training, and a model evaluation. In Kubeflow, these are very efficiently run because they're created all as Docker containers that can scale out or scale in as necessary. But look, it takes a little bit of time to build all those Docker containers and to write all the code to make this pipeline run as it's supposed to. That's where one of the automations inside of Kubeflow saves data scientists a lot of time. It's called Kale. If you turn on Kale, it's an open source extension. What it allows you to do, as you can see, is to tag cells within your notebook that will become a pipeline step. So I just come in here and I say, my first step, again, in my pipeline is going to be load data. I tag it as a pipeline step. I give it a name, load data. It doesn't depend on anything because it's the first step and whether I'm using GPUs or not. All the code that comes behind this tag will now be in this pipeline step called load data. And that's created when I hit this compile and run button. But before I do that, I just want to show you that I have 4 other steps in this pipeline. I have data preprocessing. As you can see, I've tagged this as a pipeline step. I've given it a name, data preprocessing, and I've said what it depends upon. Again, it depends upon my load data. And I have a few other steps here, right? Model training, and my last step here, model evaluation. Now, the important part that I prefaced this about was I want to run multiple iterations of this. So when I'm running Kale, I may want to call this version 2, for example. So when I click and run here and I build my pipeline, I get a second version of this pipeline, and that I can use and modify and debug from and experiment from. The other nice thing that happens in this building of this pipeline is I didn't have to manually build any of these Docker containers, right? I didn't have to take that code and chop it all up and put it into Docker containers and put those into a repo and then write some pipelines DSL code, domain specific language code to string all this together. It was all done when I hit this compile and run button here. The other thing that it does is really nice, besides this automated process, is it snapshots each of these steps before and after each of these steps run. Now, why is that important? Well, I may want to, at some time in the future, reproduce this, either because I'm getting audited or because the guy left, or I've got new, the gal left and I need to do a new iteration. So that's where this snapshot store becomes really nice in Kubeflow. And you can see I've got buckets here where I'm snapshotting my notebooks, my open vaccine. This is my pipeline. If I go into it, you can see I have multiple iterations here. This is my first version, version 1. I have here version 2. And if I look at version 2, in this version, you'll see I have 8 snapshots that were taken. I have a snapshot at the beginning of load data and at the end of load data, at the beginning of pre-processed data and at the end of pre-processed data, and model training as well as model evaluation. Now, why is this important? Well, because now I can reproduce or actually go and do more experimentation very simply. If I want to go and create a new notebook based upon my pipeline at a certain step, all I have to do is go into my notebooks form and create a new notebook server. And I can call this, for example, debug, because maybe I made a mistake in my model and I want to debug the pre-processing step. This icon here allows me from the form to go and look at my snapshot store and bring up the versions that I was using. I could replicate a notebook or a pipeline, but I'm going to go into my pipeline. And remember my last version 2 pipeline, I had 8 snapshots. I'm going to go look at those. I want to go and reproduce my pre-processed data step exactly as it looked before I did any modifications, because I think I made a mistake there. I click on this and look what it does. It automatically fills in the image that I was using. It brings in the CPU and RAM and sets those appropriately. It also brings a workspace volume in that has all my code, all my data, all my downloaded packages and libraries, as well as my metadata. And now if I hit launch, this brings me up into my notebook, and look what it does. It takes me right to the step I wanted to go to, pre-process data. And if I look in here, I have all my data and all my code is available to me. So this is just a couple of very fast, I went through it very quickly. I know examples of how to do some work protection of your notebook and your pipelines, as well as how to debug a pipeline step using integrated data management. Now, Kubeflow has a lot of great users. You've seen people like LinkedIn come in and talk about doubling the effectiveness of their ML engineers, or Spotify, 7 times more experiments, Gojek, 100 million ride-hailing booking jobs, or even cruise automation who creates General Motors Super Cruise project for their autonomous vehicle. And this is impacting not just the way that they do business, but also the equity, I think, that they raise. And you can see how well these companies have done in billions of dollars in market cap. Again, our talk is Tuesday on machine learning, primarily how to maximize the productivity of machine learning of your platform using Kubeflow 1.4. And I think this will really help you think about the KPIs that you want to use. How many models am I getting out? And how am I simplifying the life of my data scientists and ML engineers? And then the second talk is on model risk management. It's a workshop. You'll have a variety of perspectives from academia and from industry, leading people that can answer questions about any of the tough topics that you have. Our whole goal here is to accelerate your models to market. And hopefully, as you see these talks, we'll be able to do more discussion and demonstration that will be very useful for you in your present and future jobs. Thanks for your time.
I'm going to present the first 10 slides, and Elvin will present the next. So we are presenting a workshop on MLOps on October 15th, myself and Elvin, and it will be a 4-hour workshop. And what we want to talk about is, what is MLOps? MLOps is the lifecycle management and discipline for machine learning. So you may have heard of DevOps. So you have heard of DevOps, which is very commonplace, which consists of data pipelining, scalable development. And now that we have ML, we want to do MLOps, which is the data pipelining and scalable development. This is the data engineering, this is software engineering, and CI/CD is the process. In terms of the model development, you have the ML, which is the model prototyping. And when it intersects both data pipelining as well as the scalable system deployment, that whole intersection space is called MLOps. And ML is primarily data science, but MLOps is the intersection of data science with data pipelining and scalable deployment. So if you look at DevOps, a part of DevOps, which is called continuous integration, which consists of several steps. It consists of check out your code, you complete your task, you validate against the code base, you perform unit testing, and remerge the code. Next one is the CD, which is consists of build, test, and the last one is release. And the third one is continuous training, which is monitor, measure, retrain, and serve. Okay. So now if you look at CI, CD, we have the third one, which is continuous training. And that area of intersection is what MLOps is. So DevOps, you test and validate code. MLOps, you also test and validate data schemas as well as the ML models. In DevOps, you focus on a single software package for service. Here you consider the whole system, the ML training pipeline, monitoring, and so on and so forth. In DevOps, you deploy the code and move the code to the next task. And in MLOps, you are continuously monitoring and retraining and serving the model. So MLOps, you test and validate the data as well as model. You test the whole system and the ML training pipeline, as well as you constantly monitor, retrain, and serve the model. In terms of the ML pipeline, and Elvin will present more on the ML pipeline, you have the raw data, you have the data extraction, you have the data analysis, and you have the data preparation. That is all to do with data. It's shown in blue here. Next one is the ML part, which is model training, model evaluation, model validation. Then you have the trained model, you create the model registry, and you have the prediction service, and you have performance monitoring. So, and if the performance monitoring doesn't succeed, then you regenerate data or you retrain the model. So we are going to talk about also what are the different phases of MLOps in the next 5-10 minutes. And we are going to talk about what we have built as a template, as a software template, which will allow you to go through the phases. So you have the machine learning, which is data processing, model development, evaluation. You have the development, which is CI/CD building, model integration, latency, and operations, which is continuous monitoring, feedback, and model delivery. So you also have to understand that MLOps has different meaning for different people, depending on the maturity level of the customer. If you're in level 0, then you build and deploy manually, then you have limited MLOps, okay? If you are in level 1, where you're automatically training to automatic the training phase, then you have managed MLOps. This is what we do in what is called Vertex in GCP, in Google Cloud Platform. And level 2 is the highest level of MLOps, where you not only build and manage the models, but you also automate the training, validation, and deployment. So that's my 5 minutes, and I'll let Elvin talk about the remaining piece. Elvin, do you want to project, or should I continue?
I think you can continue, Chanchal. Thank you.
Chanchal, we have a question in Q&A from Ramakant. Do you want to answer now, or?
Let's finish it, and then we'll answer all the questions.
Sure.
Cool, awesome. Yeah, so Chanchal just to talk about what is MLOps, why we need MLOps, and what's the difference between MLOps with regular DevOps, right? What's the particular interesting features of MLOps? So our workshop will cover this content in more details with a more concrete example. It's sharing you a template of how we do MLOps for GCP customers at Google. So for MLOps journey, we usually have like 4 different stages from beginning to the end. So we have the build a prototype stage, which is also called a dev stage. We also have the test stage, where we build ML pipeline. And we also, the next stage is a validate stage, where we validate and stage ML pipelines into a validation environment. And the final stage will be the production stage, where we deploy the ML pipeline into a production environment. So to start your use case, you build a prototype, which allows you to accelerate, to build a acceptable machine learning model for your particular use case. You have to set up essential GCP infrastructures if you want to deploy a model on GCP. If you want to deploy models on other cloud providers or on-premise, you also have to set up the necessary infrastructure, your VMs, your GPUs, your TPUs, etc. And also you have to gather together your internal technical teams, make sure they are ready to build you have the right resources to build the ML models. That's the start of your use case. Then you move from dev phase to test phase. At this stage, you have to have a stable and validated model. So you have to make sure your model has, Chanchal, I think you have exit the presentation mode. Yeah, here we go. So you have to make sure you have a stable and validated model with acceptable performance. So yeah, so talking about the validation, talking about moving from dev to test, we have to make sure we have a stable and a validated model with acceptable performance. We have to have the modeling pipeline validated with Python notebook template. We also have internal teams ready for ML development on their GCP project. So then when we finish the test, we are trying to validate the ML pipeline instead of the model itself. Then we have to create the ML pipeline on the GCP project or any cloud providers you have. I'll talk about the details of the pipelines and the options, how you can build ML pipelines in the later slides. And you have to choose your orchestrator to orchestrate the entire pipeline from the beginning to the end, like for example, from pre-processing to training the model to post-processing to model validation, things like that. And you have to determine the infrastructure needed for production. And the final stage, you're going to deploy a scalable, composable, and secure ML pipeline on the project. And you have to consider other things like security, assets deployment, and model monitoring, and how do you want to have the trade-off between model speed and model size, things like that. And you have to provision the production cluster to actually host your models for prediction and inferences. So next slide, please. Yes.
Yeah. Thank you.
Next slide, please. Yeah. And ML pipeline example and properties. So here we are just showing two typical pipelines. One is for training, and the other one is for prediction. So for a typical training pipeline, you start from ingesting the data, and you do some data preparation, pre-processing, and you train a model. After training, probably you want to do some hyperparameter tuning to find the best combination of hyperparameters, and you want to have the final training, which you train with a large epochs number, many iterations to have your final version of the model. And you go to model deployment and model evaluation, actually evaluate the model performance. If it's good enough, then you deploy the model to some endpoints. And for prediction pipeline, similar thing, you also want to do the data preparation, make sure you process the data the same fashion as your training pipeline, so you don't have this mismatching between training and prediction. And then you use model artifacts to actually do the inference job. And you can also add a model explanation component at the end to try to explain why the model gives such prediction results. And you also have the model monitoring component, which monitor the number of queries per second, or how the payload of your model, what's the latency of the model prediction, and things like that, right? So the good thing about having an ML pipeline orchestrator is, at least on the right-hand side. So first of all, having such a pipeline in this fashion allows you to solve your case faster and more easily. And the second bullet point is easy to deploy, right? So it can be deployed on premise, on GCP, or on other cloud providers, even only if you have a cluster, Kubernetes clusters running. So it's scalable. It can be automatically scaled based on your needs. So you can scale the prediction machine based on your needs. Like if you see the latency is increasing, you have too many queries per second, you can automatically set the prediction components to be scale up and to handle the work more efficiently. Composable means actually each component, or say each step within the machine learning pipeline is is an individual component. You can mix match each other, and you can try to use this as like a Lego blocks and try to connect those together to build the pipeline that fits you the best. And orchestrated means the entire pipeline was orchestrated and managed by certain software, either Vertex AI provided by Google or Kubeflow or TFX, right? So, and the last one is secure, which means you should have a good authentication and secure setup for a user to use this pipeline, not allowing anyone with a harm intention to actually get access to your data.
Awesome.
So yeah, next slide, please.
So I think we should quickly cover the stages of the MLOps.
Yeah. Yes, I can quickly go through those slides. Yeah. So MLOps template features, we have different choices of frameworks, which you can choose your own frameworks. TensorFlow, XGBoost, scikit-learn, AutoML, or PyTorch. In our template, I will show 2 examples of TensorFlow XGBoost, but you can choose your own preference with other machine learning frameworks. And also, we have different stage of MLOps that is already covering the previous slide. We have dev, test, validation, and prod stages through the entire development process. Next slide, please. Again, the dev stage, we cover things like the data. So we have to make sure we use the correct data for building the model. Types of data is very important. Are you training the model with structured data as the tables, or unstructured data like images or natural languages? Pre-processing, right? You have to find out the correct tool to process your data in parallel fashion and in a scalable fashion. And you can use Dataprime, which provided by provided by Google. You can use Dataflow, which is just a Google version of PowerShell Beam. You can use BigQuery or whatever, just to find the right tool for your data. Feature store, GCP provides nice feature store feature where you can have different versions of the feature in a centralized place to be used for training different types of models. And for dev, we're talking about Vertex AI modeling. So Vertex AI is a Google product which is orchestrator of your, or say it's an umbrella containing many different components. One is the Vertex pipeline, it's the orchestrator of the machine learning pipeline, but under Vertex under the Vertex AI, you also have notebooks. It's just the regular Jupyter notebooks, which is handy for a data scientist. You have source control. You also have a nice training feature, which you can easily configure your VM for training a machine learning model, and you can also easily configure your hyperparameter tuning jobs. And we will cover model deployment, prediction in a batch or online fashion. Maybe if we have more time, we can explain about model explanations and the model monitoring. Yeah, next slide, please.
Correct.
And so the test stage is, test stage, we have ML pipelines, orchestration, infrastructure, scale the model, right? So I just want to talk about the infrastructure. You have this choice of choosing your CPU, GPU, or TPU, which is a very easy configuration within GCP if you want to use Vertex AI. So next slide, please. And validation stage, here we already built the model. We also built the machine learning pipeline. Now we need to do some testing. We do unit testing. We also do integration testing. Make sure the pipeline is auditable and it's ready to be used in production environment. So then next slide, we reach the final stage of the production template, production stage. At this stage, we are actually deploying the model into a real production environment. So we have to consider something is never considered by, for example, academic machine learning users, right? So we have to consider about model explanation. If we see a prediction, we have to try to explain the model either to meet the regulatory purpose or try to explain to the key stakeholders, things like that. We have model monitoring to monitor either the feature or the model performance itself. We also have a model lifecycle management and security setup and site and provision cluster into production. So
okay,
that's